Hi guys, we're gonna do I'm gonna do, not you, a lab to show you how to find the specific heat of a metal. I'll post the PDF of the lab document. You can read through it and especially read the pre-lab discussion on it, and then I will post another video doing the calculations. Remember that we're talking about thermodynamics and heat and temperature. I have a setup here of a 200 gram brass mass in a beaker of water. While they're sitting together, they're at thermal equilibrium. And the process of this lab is to actually heat them together, add enough energy from the burner to make the water boil. Since they come up to temperature together, that means that the boiling temperature of the water, which should be 100 degrees Celsius, and the temperature of the metal should be the same as well. We're going to use a device called a calorimeter. Ours are aluminum cans with another aluminum can and a ring, and then we add one more layer insulation, so we've got a little dead space here. Remember, air is a poor conductor of heat. That's why we have double pane windows. So this is kind of like a double pane aluminum window, if you will. This little gizmo is a stir rod, and then there's a lid. Lots of, you can get really good results by just using the styrofoam cup, but I'm going to use it with the lid and the whole calorimeter device since I have one. So in the instructions it says to put 50 milliliters of water into the calorimeter, so that's what I just did. The next thing I'm going to do is get the temperature of both the boiling water and the room temperature water. So, Lord willing, the boiling water is going to tell me it's 100 degrees. It's really important to suspend the mass so that it's not touching the bottom, and to make sure the thermometer doesn't touch the sides of the beaker or the metal or the bottom of the beaker where it's the hottest. This gives you a pretty good visual. Also in boiling, you're actually, those little bubbles that you see aren't bubbles of air, they're actually bubbles of water as a gas. So my thermometer this time is reading 98.2, and then I'm going to put it into the beaker, the calorimeter, and get the temperature of the water. So 98.2 is the boiling temperature, and you're going to go, well, what the heck? Have you been lying to me all my life? There's always a little bit of variation in the thermometers. Also today is about, looks like it's about to start storming, so atmospheric pressure is actually lower, so the boiling point of the water will actually be lower as well. Some of you may experience that camping up in the mountains, that the water comes to a boil, but the stuff takes longer to cook, and that's because it's not at a high enough temperature. So the water in my calorimeter looks to be 20.8, so 98.2, 20.8. Next thing I'm going to do is turn off my burner, put the lid off to the side on the calorimeter, and then very gingerly unwrap the yarn from around the clamp. I'm going to place that 200 gram mass into my calorimeter and mix up and down the water in the styrofoam cup. And as I'm doing that, the water's temperature is going up from 20.8. I also have to be careful again not to touch the metal with the thermometer, which is a little bit tricky, but we'll do that. So we're going to wait until the temperature stops changing. That's how we'll know they're at thermal equilibrium. I'm going to keep mixing. The lab says to do 3 trials. I'm only going to do 1. I hope you'll forgive me. It's a lot more fun if you do it yourself. Okay, that looks pretty good. 39.6. I'm going to record all the data and then I'll record how to do the calculations later. Take care.